So as an example, let's suppose I was trying to evaluate exactly. Ooh, my handwriting is horrible to say. Evaluate exactly sine of pi over 12. Okay, and there are actually two ways to do this problem. There are some tricks. So then evaluate exactly sine of pi over 12. Well, is pi over 12 one of the nice angles on our unit circle? No. And so we need to figure out what pi over 12 is. I know, though, that there's a formula called the half-angle formula. And so if I could take pi over 12 and rewrite it as 1/2 of something else, then what would theta have to be? And how would I figure that out? So yeah, so we would multiply both sides by 2. And then I could know what this angle theta was. So then that cancels there. And so this angle theta is going to be pi over 6. Okay. So this is our angle theta. And so what I'm going to do is use the half-angle identity. And the half-angle identity says that the sine of theta over 2 is equal to plus or minus the square root, and I think it's over 2. Is that right? You guys have it in front of you? Okay, over 2. And it's going to be 1 minus cosine of theta. All right. So then this is the identity I'm going to use to solve this problem. And if I look carefully, this right here is the same as, using the calculations we did, this is the same as sine of pi over 6 divided by 2. That's what we just figured out here. 1/2 of pi over 6. Okay, and so now I have my theta is pi over 6. So theta is pi over 6. Theta over 2 is pi over 12. So there's my pi over 12 right there. So sine of pi over 12 equals, because that's theta over 2. And then over here, I can plug in theta, which is pi over 6. So then 1 minus cosine of pi over 6 over 2. Okay. Now, I need to be real careful about how I write this. This square root goes all the way down. And that is one area where sometimes students make a mistake, is they don't get, they forget that the 2 is inside the square root. So then now that we know the format of our answer, so we converted to the half-angle identity by figuring out what half of what is pi over 12. And the thing that we take half of is theta, which is pi over 6. That means theta over 2 is pi over 12. So now I have this. So then we have right now that the sine of pi over 12 is plus or minus the square root of 1 minus cosine of pi over 6 over 2. And now is where the hard work comes in, because we need to simplify this. And what is the cosine of pi over 6? Square root of 3 over 2. So 1 minus square root of 3 over 2. This is over 2. We are going to use a trick that is commonly used with half angle. We're going to get rid of the denominators in the top so that I don't have a compound fraction. And this is the general strategy. We don't want fractions in the top. So what number could I multiply by that would get rid of all the fractions? 2. Okay, so we're going to multiply top by bottom, top by 2 and bottom by 2. And what would I end up with in the top? There we go. Okay. Yeah. And then what happens in the bottom? 4. So then I have plus or minus, and I'm going to split this apart now. And what is the square root of 4? It's just 2. So now we have a rationalized fraction. So there's no roots in the denominator. It does have a root within a root, and that is the one ugly part of half-angle identities. It's going to happen. Okay. Usually we'll just leave them in this form, but the problem is can the sine of pi over 12 be two different answers? No, because what quadrant is pi over 12 in? If I look here, pi over 12 is in quadrant 1. Okay. And since I know it's in quadrant 1, is sine positive or negative in quadrant 1? It's positive. So then when I come down here, I know that I have to use the positive sign. And so my final answer would be that the sine of pi over 12 is positive root 2 minus square root of 3 all over 2. And then that would be the exact value of sine of pi over 12, which you can get this answer. I don't know if you guys remember, we got the answer using the sum and difference formulas. It looks different, but it's the same answer. So if you do this using sum and difference, you're going to end up with like the square root of 6 minus the square root of 2 over 4. Okay, so find cosine of u over 2 if what? Negative 0.365, like that. Okay, and so the first thing I'm going to do is start with the cosine of u over 2 and just write out what I know that is. It's either plus or minus square root. Did they say a quadrant? Okay, yeah, this one we do need to know a quadrant because we don't have the original angle. So quadrant 4. Okay, so then is u in quadrant 4 or is a u over 2 in quadrant 4? Okay, so u is an element of quadrant 4. Okay. So then if we write out, the only difference here is going to be that that's a plus instead of a minus, and this is still over 2. And do I have the identity written correctly? So then, let's see. So I know that I have to get a cosine of u, but right now I only have sine of u. However, I remember that there's another identity. Sine squared of theta plus cosine squared of theta is always equal to 1. Yes, so it's always equal to 1. Oh, 1. So then what I need to do is plug in what I know here. Sine, I know. So I would have negative 0.365 squared plus cosine squared equals 1. I could have rearranged this whole equation and I would have found that cosine of theta is plus or minus the square root of 1 minus sine of theta. Okay, so if I had taken this identity, subtracted sine squared, 1 minus sine squared, sorry. Subtract sine squared and then take the square root of both sides, then I'd end up with that. Okay, but I can also just plug it in directly and manipulate it that way. Whichever way is easier for you. So cosine of theta would be plus or minus the square root of 1 minus 0.365 squared, and then I can go to my handy dandy calculator and evaluate that out. So, oh, yes, it is. Is it going to matter though? No, because when you square it, it's going to make it positive. But that's why there's a plus or minus out here. So now that I have that, this is plus or minus, and then I can evaluate that out, and I think I got this right. So 0.9310. Does that look right? And if I keep going, it's 0.75 after that. So I'm actually going to use as much accuracy as I can in my calculations so I don't lose accuracy later on. Okay. And so now I need to know though, theta in my problem is my u here. I should have called this u, but here's my u. So cosine of u, because u is the angle I'm interested in, it's going to be positive. There you go. Because it's in quadrant 4. So let's go ahead and plug in what we found out. We found out that cosine of u is 1 plus a positive 0.9310075. And I'm going to use as much accuracy as I can to do this calculation so I don't lose any accuracy in my final answer. And then I'll go to my calculator. It'll be plus or minus some number that I'll get out of that. So if I go to my calculator and type that in, and it looks like 0.9826005. Did you guys get the same thing? Yeah, but here's where the trick comes in. Is it plus or is it minus? So u is in quadrant 4, which means it was between, okay, so in degrees it'd be 270 and 360. So that means if I wanted to find out what u over 2 is between, I would divide everything by 2. And then I'd have 135 less than u over 2 less than 180. And what quadrant are these angles in? These are all in quadrant 2. Okay. And so in quadrant 2 is cosine positive or negative. So it's less than 0. So then in this case, it would be minus. So negative 0.9826, we'll say approximately. And then that would be our value for cosine of u over 2.